What if Earth became a lava planet? In this video, we'll dive into this mind-bending scenario. A breathtaking blue marble, swirled with clouds of brilliant white. It is a jewel of life, suspended in the cosmic dark. Oceans glitter under the sun's gentle touch. Continents of green and brown tell the story of seasons, of forests, and of deserts. This is Earth. Our home. The only home we have ever known. For millennia, it has nurtured life in its countless beautiful forms. From this distance, everything seems peaceful, everything seems permanent. But that illusion is about to be shattered in the most spectacular and terrifying way imaginable. Zooming closer, the familiar patterns begin to warp. Something is wrong. A faint, angry glow starts to pulse beneath the clouds. It is not the familiar, comforting light of cities at night. This is a deeper, more primal light. A menacing orange that bleeds through the thin veil of our atmosphere. The glow is not confined to one place. It appears in vast, spreading networks across the continents like fiery veins on a dying leaf. The planet seems to be breathing fire. The serene blue marble is transforming into a sphere of incandescent rage, its surface beginning to writhe and churn with an unimaginable inner heat. On the ground, the signs are far more immediate and terrifying. The land itself is betraying us. Great cracks, miles long, tear open the ground. They glow with a fierce, hellish light from deep within the planet. The very air shimmers with heat, even in the coldest regions of the globe. The planet is groaning. It is a sound that travels not through the air, but through the solid rock beneath our feet. A deep, resonant vibration that signals a profound and catastrophic change. The world we knew, the solid ground we trusted, is beginning to melt away beneath us. This is not a nightmare. It is a geophysical reality unfolding in real time. The delicate balance that has sustained our world for eons is collapsing. The heat that once powered life-giving geological cycles is now escaping its ancient prison. It is overwhelming the planet's thin, fragile crust. We are witnessing the birth of a new, terrible world, a lava planet. The transformation has begun, and the tranquil blue marble we once called home is now a canvas for a planetary inferno, its final, fiery masterpiece. Our first warnings did not come from a fiery spectacle in the sky. They came as faint whispers from the heart of the planet itself. Deep within scientific observatories, scattered across the globe, dedicated researchers were listening. They were monitoring the planet's pulse. They used instruments of incredible sensitivity. Seismometers designed to detect the faintest tremors began to register a constant low-frequency hum. It was a vibration that had no precedent. It was not the signature of a typical earthquake, but something far more profound, a planetary thrum that suggested the entire inner structure of our world was in a state of agitation. The data streamed in from every corner of the Earth. Thermal sensors on satellites, which normally map sea surface temperatures or track wildfires, began to show alarming anomalies. Huge swaths of the continental crust were heating up, not just by a few degrees, but by dozens. It was as if a hidden furnace had been turned up to its maximum setting. Dr. Aris Thorne, a leading geophysicist at the Global Geodynamic Institute, was one of the first to connect the dots. He looked at the seismic data, the thermal maps, and the satellite readings. The conclusion was inescapable, yet it defied all known models of planetary science. Geophysical models, complex computer simulations of Earth's interior, were run and rerun. Every time they returned the same terrifying result. The models predicted a runaway thermal event originating from the boundary between the core and the mantle. Magnetic field detectors, both on the ground and in orbit, also picked up bizarre fluctuations. Earth's magnetic shield, the invisible force field that protects us from solar radiation, was flickering like a dying candle. It was becoming unstable, weakening in some areas and surging erratically in others. The planet's very soul seemed to be in turmoil. The scientific community was in a state of controlled panic. Papers were published in a frenzy. Conferences were held online with experts from around the world sharing their terrifying findings. The evidence was overwhelming. The seismic hum, the crustal heating, the magnetic instability, they were all symptoms of the same terminal illness. The planet's internal heat engine was breaking down. The energy that should have been released slowly over millions of years through volcanoes and tectonic plate movements was about to be unleashed all at once. The whispers from below were becoming a deafening roar. To understand this planetary catastrophe, we must journey to the center of our world. Earth is structured in layers like an onion. At its heart lies the core, a superheated ball of iron and nickel. The outer core is liquid, while the inner core is solid due to immense pressure. Surrounding the core is the mantle, a thick layer of semi-molten rock that churns in slow-motion currents over millions of years. This movement drives the tectonic plates of the crust, the thin, brittle shell we live on. This delicate system is powered by the immense heat left over from the planet's formation and from the decay of radioactive elements. For billions of years, this system has been in a stable equilibrium. The crust has acted as a protective lid, insulating the surface from the inferno below. It allows heat to escape in controlled ways through volcanic eruptions and at mid-ocean ridges. But what if that system failed? What if something were to disrupt the slow, steady convection of the mantle? Latest geophysical research suggests a theoretical scenario for this: a mantle overturn event. This could be triggered by a sudden, massive release of energy from the core mantle boundary, a place of extreme temperatures and pressures we are only just beginning to understand. In this scenario, a superplume of unbelievably hot material from the deepest parts of the mantle could begin to rise. Not like a normal volcanic plume, but a colossal upwelling the size of a continent. As this wave of superheated rock surged upwards, it would rapidly melt everything in its path. It would destabilize the entire mantle, causing a chain reaction. The planet's internal thermostat would be broken. Instead of a slow, steady release of heat, the planet's internal energy would rush towards the surface in a single, cataclysmic event. The crust, our solid, dependable ground, is only a few tens of kilometers thick. It is a fragile eggshell atop a sea of fire. Faced with such a colossal thermal surge from below, it would stand no chance. It would crack, it would melt, it would be consumed. The very rock beneath our feet would lose its integrity, turning from solid to liquid. The process would not be instantaneous, but on a geological timescale, it would be terrifyingly fast. The entire surface of the planet would be resurfaced with pristine, glowing magma. Earth would be reborn as a Hadean world, a planet of lava, just as it was in its earliest, most violent days. The first definitive sign for the public was not a scientific paper, but the ground itself screaming in protest. The constant, low-frequency hum detected by scientists erupted into a global earthquake storm. It was not one earthquake, but thousands. Tectonic plates, which normally grind past each other at a few centimeters per year, began to shudder and fracture violently. Fault lines that had been dormant for millennia ruptured with unimaginable force. Cities built near these zones were the first to fall. Buildings of steel and concrete, monuments to human ingenuity, were shaken to dust in minutes. Simultaneously, the world's volcanoes awoke in a furious, synchronized chorus. Not just the famous ones that line the Ring of Fire, but new ones, tearing open the earth in places that had never known volcanic activity. Supervolcanoes like Yellowstone, which had slumbered for hundreds of thousands of years, did not just erupt, they exploded. They blasted trillions of tons of ash, rock and gas into the atmosphere, creating shock waves that circled the globe. The sky in a 1,000-mile radius turned to instant night, choked with a blizzard of gray, suffocating ash. The very geography of our planet began to change. As the crust buckled under the immense heat from below, mountain ranges were thrust upwards with violent speed, only to collapse back into molten rubble. Continental shelves crumbled into the sea, triggering mega tsunamis of a scale never before witnessed. These were not waves. They were moving walls of water, hundreds of meters high, that scoured coastlines clean of all life and all human presence. They traveled inland for hundreds of miles, carrying the debris of our civilization with them before the water itself began to boil. The planet was tearing itself apart from the inside out. The process was a terrifying feedback loop. The massive earthquakes created new pathways for the magma to reach the surface. The colossal volcanic eruptions released immense pressure, causing further crustal instability and triggering more earthquakes. It was the complete and utter failure of the geological systems that had governed our world for eons. The solid ground, the very concept of a stable Earth, was gone. It was being replaced by a sea of fire, a churning, chaotic landscape where the only constant was destruction. The Earth's oceans, the cradle of life, were once vast and deep. They covered more than 2/3 of our planet's surface. They regulated our climate and held an astonishing diversity of life. But in the face of this planetary fever, they were nothing more than a shallow pan of water on a colossal stove. As lava poured onto the ocean floors and the crust heated from below, the water began to warm. At first it was a subtle change, but the process accelerated with terrifying speed. The world's coral reefs, already stressed by climate change, were the first to go, bleached to a ghostly white before the water around them began to simmer. Soon, the simmering turned to a rolling boil. The surface of the oceans began to churn with steam and froth. Imagine the entire Pacific Ocean, a body of water so vast it defies comprehension, steaming like a kettle. The sound would have been a continuous, deafening roar, audible from space if there were any air to carry it. The heat was so intense that marine life was cooked in its own habitat. Whales, sharks, and countless fish perished in the superheated water. The once teeming ecosystems of the deep, full of bizarre and wonderful creatures, were extinguished in a matter of days. The boiling of the oceans unleashed an incredible amount of water vapor into the atmosphere. This created a runaway greenhouse effect of unimaginable power. The steam formed a thick, suffocating blanket around the planet, trapping even more heat. This accelerated the boiling, creating a vicious cycle of heating and evaporation. The sky, already dark with volcanic ash, became thick with dense, scalding clouds. Rain fell not as water, but as a torrential downpour of hot, acidic mud. It was a deluge that stripped landscapes bare and dissolved everything it touched. Eventually, the oceans boiled away completely. Where there were once deep blue seas, there were now vast, empty basins of cracked, salt-encrusted rock. These basins quickly became channels for the ever-spreading lava. The last of the water, the very essence of life on our planet, vanished into the choked, toxic atmosphere. The blue marble was gone forever. In its place was a dry, scorched husk, its empty ocean beds now glowing with the light of the inferno that had consumed them. The planet had lost its lifeblood. As the oceans boiled and the volcanoes erupted, our atmosphere, the thin, precious layer of gas that sustained us, was transformed into a poisonous soup. The air we breathed became our enemy. The colossal volcanic eruptions did not just spew ash, they pumped billions of tons of toxic gases directly into the sky. Sulfur dioxide, carbon dioxide, and hydrogen sulfide filled the air. The sulfur dioxide reacted with the steam from the boiling oceans to form clouds of sulfuric acid. The sky did not just rain hot mud, it rained acid. This toxic blanket changed the very nature of our sky. Sunlight could no longer penetrate the thick layers of ash and acid clouds. The planet was plunged into a perpetual, gloomy twilight illuminated only by the terrifying orange glow of the lava below. Photosynthesis, the process that powers nearly all life on Earth, stopped completely. Plants and phytoplankton, the foundation of our food webs, withered and died on a global scale. With their demise, the production of oxygen ceased. The air became not only toxic but also unbreathable. The weather systems we knew became a distant memory. The immense heat from the surface and the thick, soupy atmosphere created hypercanes, cyclonic storms far more powerful than any hurricane ever recorded. These storms, hundreds of miles across, raged over the lava plains. They were driven by the extreme temperature differences between the superheated surface and the upper atmosphere. Instead of wind and rain, they whipped up cyclones of ash, toxic gas, and searingly hot air, with winds powerful enough to tear rock from the ground. The sky was a battlefield of violent, elemental forces. Ultimately, the atmosphere itself began to be stripped away. The weakening of Earth's magnetic field left our planet vulnerable to the solar wind, a constant stream of charged particles from the sun. Without this magnetic shield, the solar wind began to erode the upper layers of our atmosphere, carrying the gases of our world away into space. The air, already a poisonous, choking fog, was now slowly but surely being lost to the void. The final protective blanket of our planet was unraveling, leaving the molten surface exposed to the harsh vacuum of space. For the living things of this world, there was no escape. There was no ark. The scale of the disaster was too vast, too absolute. The collapse of ecosystems was swift and total. Forests, the green lungs of our planet, were the first to burn. They were consumed by colossal firestorms that swept across continents, ignited by the spreading lava flows and the searing heat. Animals fled in terror, but there was nowhere to run. The flames were everywhere. The ground was shaking apart. The very air was poison. The symphony of life, the chorus of birds, the hum of insects fell silent. For humanity, the end came with brutal efficiency. Our cities, our proud monuments to civilization, became death traps. The global earthquake storm leveled our buildings, the lava flows entombed our streets, The toxic air seeped into every shelter, infrastructure collapsed instantly, power grids failed, communication networks went dark, there was no organized response, no government to issue warnings. There was only chaos and survival on a moment-by-moment basis. People were faced with an environment that was fundamentally incompatible with human life. In the final days, the last pockets of humanity would have sought refuge in the most desperate of places, perhaps deep underground in hardened military bunkers or scientific research stations. But even these shelters were temporary. The relentless heat from the planet's core would have cooked them from below. The seismic shocks would have compromised their structural integrity. The air filtration systems would have failed against the sheer volume of toxic gas. The last moments of our species would have been spent in darkness, listening to the roar of a world being unmade. This was not just the extinction of a single species, it was the sterilization of an entire planet. From the most complex mammal to the simplest microbe, life was scoured from the face of the earth. Even the extremophiles, the hardy bacteria that thrive in volcanic vents or deep-sea trenches, could not survive this. Their habitats were either vaporized or fundamentally altered beyond their ability to adapt. The intricate 3.5-billion-year-old tapestry of life on Earth was burned away, leaving behind a sterile molten rock. The story of life on our world was over. While life on the surface was extinguished, a final remnant of humanity's presence remained. In orbit, hundreds of miles above the inferno, were our silent watchers, our satellites. These marvels of technology, our eyes in the sky, provided the last, horrifying views of our world's demise. For a time they continued to function, relaying data that painted a picture of utter devastation. Weather satellites showed the churning hypercanes of ash. GPS satellites registered the ground deforming and moving by meters per second. Earth observation satellites watched as continents glowed brighter and brighter before dissolving into the magma sea. However, these watchers were not safe. The dying planet fought back against them. The massive thermal radiation from the molten surface began to overheat their sensitive electronic components. Many satellites simply cooked in their orbits, their systems failing under the immense heat bath rising from below. The collapse of the magnetic field was even more dangerous. Without its protection, the satellites were exposed to the full, raw fury of the sun. Intense solar flares, which would normally be deflected, slammed into them, frying their circuits and destroying their solar panels. The data streams coming back to automated receiving stations on the Moon or Mars, if we had them, would have become erratic and then stopped one by one. The final signals would have been a chaotic mess of sensor failures and system alerts. The most robust, military-grade satellites might have lasted the longest, their hardened systems resisting the heat and radiation for a few more days or even weeks. They would have continued their silent vigil, faithfully documenting the end of their own world, until they too succumbed to the planetary death throes. Eventually, the last satellite would fall silent. The final whisper of human technology would be extinguished, the sky above Earth would be empty of our creations, but their orbits would decay. Over the coming years and decades, their metallic carcasses would be pulled back towards the world that built them. They would streak through the thin, toxic upper atmosphere as shooting stars, burning up long before they could ever reach the molten surface. They were the final, fleeting monuments to a species that had reached for the stars, only to be consumed by the fire within its own home. In the aftermath, Earth would be a very different world. A glowing orb of orange and black, its surface a constantly churning ocean of magma. Over millions of years, it would slowly cool. A new crust would form, black and volcanic. A new atmosphere, thick with carbon dioxide and sulfur, would slowly accumulate from the outgassing of the cooling rock. It would be a hostile, sterile world, more like a young Venus than the Earth we knew. Perhaps in a billion years life might find a way to begin again. But it would be a new story with no connection to the one that came before. Studying such a terrifying scenario is not an exercise in fear, it is a profound scientific necessity. It helps us understand the life and death of planets, including our own. The geological forces that could cause such an event are the very same forces that make our planet habitable. The heat from the core that drives plate tectonics, creates our land, and powers our magnetic field is a double-edged sword. By modeling these extreme possibilities, we learn about the delicate balance that allows life to flourish. It gives us a deeper appreciation for the stability we so often take for granted. This thought experiment also extends our vision outwards, to the countless planets we are now discovering around other stars. Many of these exoplanets are so-called super-Earths in tight, hot orbits. They may well be lava worlds right now, trapped in the very state our planet has reverted to in this scenario. By understanding the geophysics of a molten Earth, we can better interpret the data we receive from these distant, fiery worlds. It helps us define the habitable zone not just in terms of temperature, but in terms of geological stability. Ultimately, imagining the end of our world is a powerful way to appreciate its beginning and its present. It reminds us that a planet is not a static object but a dynamic living system. It is a story of immense violence and incredible luck, of delicate balances that have held for eons to create this paradise. Our world, this blue marble, is a precious and perhaps fleeting anomaly in a universe that is often hostile to life. Its survival is not guaranteed, and in that knowledge lies our greatest responsibility: to understand it, to cherish it, and to protect the only home we will ever know.